Hello everybody, today I'm gonna show you how to use streaming to improve performance and reduce memory consumption. Let's say I have some user service with some users existing in database, let's call it source service, and I want to have a local cache of users in some other service, let's call it target service, so I need to transfer it somehow to fill up the local cache. To do this, I need some HTTP GET endpoints on source side to get the users and then bulk insert them to a target database. This endpoint can look like this. Just get all the users from database with no tracking and return the list of users. From a target side, I'm just get all these users and bulk insert them to a database. Let's check how it is working. I will use .NET Aspire for this example because it has nice telemetry out of the box. Right now I have 1 million users in source database and no users in target database. Let's run the application. Open target service and call initialize endpoint. All the users were transferred successfully. It took 30 seconds, which is probably fine, but memory consumption skyrockets because we hold the whole list in memory as in source service and the same in target service. This will lead to out-of-memory exception sooner or later. I'm already hearing that voice as batches, split it to batches. Okay, let's try. Usually batches are implemented like this. I added top and skip arguments. Then I need some ordering for consistent batching. I'm sorting by a primary key because any other sorting will slow down this query even more. Then skip, take and return a smaller list. On a target service, I need to know total amount of users. This should be another request. I just hard-coded it. Then I need to find some reasonable batch size. Let's take 1000. It looks reasonable. And then I need to have this ugly loops that will loop through the batches and insert each batch separately. Let's check how is it working. I will truncate the target table and run the application. Now the request is completed. Memory consumption looks much better, both in source service and in target service. But the whole request took more than 1 minute. It performed 1000 HTTP requests, made 1000 queries to a source database, and 1000 bulk inserts to a target database. But even worse, when the skip counts start growing, SQL Server doesn't happy with the big skip counts, and each subsequent request becomes slower and slower. We start from about 10 milliseconds, and in the end it's more than 100 milliseconds. So ugly code lead to ugly performance. And talking about this batch size, how can we know if 1000 is good or not? How can we calculate this number? And what if different environments have different resources? For example, we have more memory on production than on dev. Should we have different batch size for each environment? So many questions, but the real question is how many users we need to collect in memory before start writing them to a response. 1000, 100, or maybe just one is enough. If we go to Entity Framework to list async implementation, we can find out that it does nothing more than just enumerating through a result set of execution of SQL query and collecting these records in memory. But I don't need to collect them in memory, I want just to pass it to the response. So I will loop by myself through this enumerable, and when I get a single user from underlying DB data reader, I will immediately return it to the response. I wrote this code just for illustration, we don't need this loop at all. DB context is already async enumerable, so we don't need this line as well. And the resulting code will look like this. Wow, it's beautiful. Beautiful code will lead to beautiful performance. On a target size, I will use this getFromJSON as async enumerable method on HTTP client to have users as enumerable as well, not collecting them in a list. And then I pass this enumerable to bulk insert. I implemented bulk insert using SQL Server feature called table value parameters. In most examples, people usually use data table to pass collection to a table value parameter. In best case, it's list of SQL data records, but the real choice is between data table and enumerable of SQL data records. I like enumerable, I will choose second option. I have simple method that maps user to SQL data record. Select doesn't materialize anything, so I still have enumerable, and I pass this enumerable to SQL parameter. Table value parameter stores its rows in a tempdb, so effectively it will be streamed to a tempdb. So I will still have the full list in a tempdb, but not in my application memory. And then I just execute insert to a users table from table value parameters. Let's check how is it working. I will truncate target users again. And call streaming endpoint. Memory consumption is still good. And the resulting time is 11 seconds, even better than with list. Maybe these memory allocations are not so cheap. You can ask me, why do I use Entity Framework to execute raw SQL? While preparing this video, I tried to use Dapr and surprisingly found that there is a bug in Dapr that prevents from passing enumerable as a TVP. I created a small sample that reproducing this bug. I'm generating enumerable of numbers and trying to insert them using TVP, with the side effect of writing it to the console. And when I call it with argument 3, it should write to console 0, 1, 2. But the actual result is 0, 0, 1, 2. So I even downloaded the source code of Dapr and found out that they perform any on the enumerable, which causes this first enumeration. So you should be very careful dealing with enumerables. If you pass list here, you will never notice this second enumeration. But for enumerables from a database, it throws an exception that it cannot open the second reader on the same connection. At the moment I'm recording this video, this bug is still not fixed, so to pass the enumerable to a TVP, you can use either Entity Framework or plain Ado.NET. And it's possible to implement even more complicated scenarios using streaming. Let's say that initial migration of users is completed And I implemented some event create state transfer to synchronize users using some service bus events, but I didn't use any service bus library that implements transactional outbox, and eventually I started to lose events from time to time. Now my databases are not synchronized and I need to find a way to synchronize them. And if I don't know which events were actually lost, the only way to find the difference between two databases is to perform a full scan of both tables. And of course I want to do it without batches in one enumeration. There is a quite simple algorithm. I will show you an example of integers, but the same will be for GUIDs. I will iterate through both collections at once, and if elements in these collections are equal, it means that they are synchronized. If source element is less than target element, it means that there is a gap here and this element should be added to a target collection. And if source element is greater than target element, it means that there is a gap here. And this element should be deleted from a target collection. This algorithm will work for sorted collections, but I will compare IDs, which are primary keys and are sorted by definition. Here is the implementation of this algorithm. I have two enumerables, source and target, and enumerate over both of them. If they are equal, just enumerate further. If source is less than target or target enumeration has finished, then enumerate next source collection and remember this user as user to add. And if source ID is greater than target ID or source enumeration has finished, then it's user to remove. I added a new class user action, which is actually affected user and action add or remove. And as you can see, I'm returning enumerable again. I don't want to deal with these lists anymore. So to feed this algorithm, I will take source users as enumerable from the HTTP endpoint and target users from a database and pass this to the algorithm. And then the result, which is also enumerable, I'm going to pass to a table value parameter. And here again, I'm mapping user actions to SQL data records and pass it to a table value parameter. And then I just insert users with action add from a TVP and delete users with action delete. I'm using plain Ado.NET here to execute this SQL because at the moment of the execution of this method, I have already opened connection on GET. And the Entity Framework DB context is not designed to execute multiple parallel queries. Let's check how is it working. I'm going to delete one user from a target table, imitating that we lost create user event. Then I will call sync endpoint. And now my tables are synchronized again. Now I'm going to delete one user from a source table, imitating that I've lost a delete user event. On the target side, we still have all users. Let's synchronize. So now my tables are synchronized again. And now I can even delete this init endpoint because I can synchronize the full table. So I can use the sync endpoint for initial migration as well. Of course, I could stream the whole source table to a TVP and do SQL merge inside the database. It will be even simpler, but I wanted to illustrate that more complicated processing is possible using streaming. That's all for today. Thank you for your attention. You can find the link to the source code in the description.